December 19th, 1944, American infantry around Bastogne were holding foxholes that were slowly filling with snow. By dawn, soldiers couldn't bend their fingers, and their rifles were frozen to their hands. That winter, cold injuries took tens of thousands of American soldiers out of action, and in the worst cases led to amputated limbs. They had to build their own survival systems to stay alive in conditions where the standard army gear and planning did not give them enough protection. Let's see what really happened when the weather became another enemy the army failed to prepare for. War stories usually follow the bullets, but in the winter of 44, the US Army in Northwest Europe recorded over 71,000 cases of cold injury, including trench foot and frostbite. But what's even more shocking is that during the same winter, the British and Canadian forces in the same part of Europe reported around only 200 cold injury cases. That tells you the American numbers were not just about the weather. So, how did American soldiers get through a winter where their own equipment often let them down? And what did they end up doing in the field that went beyond what the supply system had managed to provide? In areas such as Bastogne and other exposed fronts, infantrymen could spend long stretches awake in foxholes, while snow built up around them, wearing the standard M1941 field jacket, often called the Parsons jacket, which army testing had already judged too light for sustained cold and wet conditions. Designers back in the United States had produced the M1943 field jacket and a layered clothing system with liners and over trousers as an improvement. But getting that new gear from depots to frontline units took time, and the advance of combat formations often outran the flow of supplies. As a result, men in places like Belgium and the Hurtgen Forest still faced severe winter weather in relatively light cotton and wool clothing, while warmer outer garments and overshoes remained in storage areas farther to the rear. Footwear brought another set of problems. Standard-issue leather combat boots were usually sized for a single heavy sock. In practice, many soldiers tried to cope with the cold by putting on 2 or 3 pairs of wool socks inside the same boot size. That extra bulk compressed the socks and reduced circulation. In cold water and slush, reduced blood flow meant a higher risk of tissue damage. Feet could swell and become painful inside stiff boots. Skin might go from pale and numb to discolored, and in serious cases infection and gangrene could develop, sometimes ending in amputation. After the war, the Army's General Board, in its report on trench foot and related problems, pointed to inadequate clothing and footgear, limited rotation of troops in and out of exposed positions, and weak enforcement of preventive measures as major reasons for the scale of cold injury. The result was that the system from design and procurement up through command decisions did not fully match the conditions at the front, and many soldiers ended up relying on their own improvised methods to stay warm and to protect their feet when official measures fell short. Improvisation often started with what looked like trash. Near places such as Bastogne and other frontline positions, soldiers picked up German propaganda leaflets, smoothed them, tore them into strips, crumpled the pieces and pushed them into their jackets, down their sleeves and around their feet inside tight boots. Others used whatever dry paper they could find. Routine orders, old newspapers, local magazines, even enemy handbills that had been dropped from the air. To someone looking on, it could seem pointless, but basic physics was on their side. Crumpled paper holds many small pockets of still air, and still air is what slows heat loss. Cloth and feathers work in the same way by holding air in place. When the air is trapped, you lose heat more slowly. When it moves freely, you cool much faster. Families with few resources had used this trick before the war by packing newspaper into gaps in walls and floors. In the mid-1940s, many people in that region remembered this as one of the harshest winters in decades, and the use of paper as insulation returned from experience rather than from any formal handbook. Moisture was the weak point. Snow, rain, sweat, and condensation could soak the paper, collapse those airspaces, and wipe out most of the benefit. That is why many soldiers kept looking for dry material whenever they halted. On marches and in abandoned villages and farmyards, any reasonably dry paper that could be crumpled and stuffed into clothing became a simple way to keep the torso a little warmer. That still left another problem that paper could not solve: contact with the ground. Lying on frozen soil pulls heat out of the body much faster than cold air alone. A thick coat cannot make up for direct contact with very cold earth. To deal with that, troops tried to get some kind of layer between themselves and the ground. In barns, straw was ideal. Spread in a deep layer, it lifted men off the floor and trapped air in its hollow stems. Where straw was not available, they cut pine branches, raked together dry leaves, or piled up tall grass from ditches into a thick mat. The important thing was not the plant material by itself, but the spaces inside the pile that slowed heat loss. In places with little vegetation, soldiers worked with the soil, scraping loose earth and brush into low mounds, or laying boards and planks across shallow pits so that their bodies rested on something other than bare wet ground. They did not need technical formulas to see the effect. Hard, damp soil chilled them quickly. A springier, drier surface gave them a better chance of staying functional. Some units went further and dug shelters below the surface. A dugout is more than a simple hole. A few feet down, the temperature of the soil stays more steady than the air above, still cold but less extreme. When a dugout was roofed with logs and covered with earth and snow, the ground itself helped hold in the warmth from bodies and small stoves. The type of soil mattered. Dry, well-drained ground could make such a shelter workable, while low, clay-heavy areas tended to collect water, leaving walls and floors damp and increasing the risk of foot problems more quickly than an open foxhole. German field doctrine already promoted systematic field construction, known as Feldmäßiger Ausbau, or field-type construction, which meant building with whatever the local terrain offered: turf, timber, stone, even blocks of snow. Partisan groups pushed the idea further. In Slovenia's Pasica Gorge, the Franja Partisan Hospital hid a group of wooden buildings in a narrow ravine, with retractable footbridges, minefields, and carefully camouflaged roofs. Over the course of its operation between 1943 and 1945, hundreds of badly wounded fighters were treated there. German forces searched the wider area but did not find the site. Places like that served both as medical facilities and as shelters that used rock, forest cover, and the insulating mass of the earth to protect those inside from weather and observation. All of these measures, though, depended on the people in them having enough food and rest to keep producing body heat. Without that, even the best insulated shelter could not stop a cold, exhausted soldier from sliding into dangerous hypothermia. In severe cold, the human body burns through food quickly just to keep its core temperature near 37 degrees Celsius. And hard work in that environment, such as long marches, digging positions, and standing guard in storms, pushes that demand higher. The US Army did have equipment that could provide heat, but it was not always practical to use it close to the front. Large open fires near forward positions were risky because the light and smoke could draw artillery. In 1942, the Quartermaster Corps asked manufacturers for a compact stove that was light, could burn various fuels, and would function in very low and very high temperatures. Coleman answered with the Model 520, often called the GI pocket stove, roughly 8.5 inches tall, about 3 pounds in weight, and capable of producing more than 5,000 BTU per hour. It could run on gasoline, aviation fuel, and other similar liquids. War correspondent Ernie Pyle, who spent much of the war alongside frontline units, later placed this stove just behind the Jeep in terms of usefulness to the ordinary soldier. German troops commonly used small Esbit stoves that burned solid fuel tablets, and British troops relied on compact Tommy cookers that used gelled alcohol or similar fuels. All of these devices made it easier to melt snow, heat drinks, and warm rations without gathering large amounts of firewood, but they were most effective in sheltered positions such as barns or well-covered dugouts. They did not remove the basic problem of a rifleman posted alone in a shallow, exposed foxhole with orders to stay awake. Addressing that kind of situation required changes in routine and leadership, not just equipment. When medical officers reviewed the very high number of trench foot and other cold injuries after the war, they did not focus only on clothing and boots. They also emphasized the role of how soldiers behaved in the cold and how officers enforced preventive measures. Many men disliked taking off their boots in freezing conditions and hesitated to pull off socks for fear of discovering serious damage. That led some to wait longer than they should. To push back against this, directives instructed small unit leaders to include regular foot checks in their duties. Socks were to be changed and dried when possible, and boots had to be removed on a schedule rather than left on indefinitely. Medical guidance at the time also noted that dehydration could make cold injury more likely, and some units tried to maintain attention to water intake as part of general health. In depots and medical areas, posters showed stark photographs of feet badly damaged by cold, with bold warnings to prevent trench foot. The aim was to encourage soldiers to follow preventive routines even when they were tired. Another line of defense involved using shared body heat. In small shelters such as dugouts, barns, or covered foxholes, two soldiers might lie close together under the same blankets with their boots off and damp socks drying nearby. In a confined, insulated space, the warmth from two people raised the temperature noticeably above that of the air outside. Units, including elite formations such as Rangers, used buddy teams not only for moving and fighting, but also for checking on each other's condition. One man could stay on watch while the other slept in a warmer spot, and they would rotate. Non-commissioned officers did not just ask whether weapons had been cleaned, they also asked whether men had looked at their partner's feet and whether socks and basic needs were being managed. In those conditions, it was not unusual for men of different ranks to share the same cramped sleeping space, because staying functional in the cold mattered more than formality. Many veterans later recalled that, in later winters, they were relieved simply not to be back in those positions. When historians piece together these accounts, a wider pattern emerges. Soldiers made use of improvised ways to stay warm, took shelter in structures that used the ground itself to moderate temperature, adopted stricter routines for foot care and hydration, and depended heavily on each other to notice early signs of trouble. At the same time, higher-level decisions had not fully anticipated the scale of the problem. Orders for winter clothing had been delayed in part because some planners expected the war in Europe to end before the worst weather arrived. Training on cold injuries varied in quality, and choices about uniforms and boots were influenced by cost as well as protection. For frontline troops, this meant dealing with both enemy forces and the effects of low temperatures. They stayed in the fight because they learned from experience, from local civilians and from medical advice, how heat and cold affected their bodies, and because they followed preventive routines that could feel burdensome after long days. Just as important, they relied on mutual support within small groups. Much of the warmth that mattered to them came not from large stores of equipment, but from small stoves, enclosed spaces, improvised insulation, and the presence of another person sharing that shelter.